Yeah, welcome back to the channel. And today's video, we are going to discuss to creating the EKS cluster through Terraform and work notes components. We are discussing today's video. This is the episode 2, section 2. And last section, we discussed about architecture. And today's, we are going to discuss workloads components and Kubernetes cluster deployment through the Terraform. Okay. First, we'll go through the workloads components. After that, we will launch the Kubernetes cluster. Okay. Otherwise, first we will go for the Kubernetes EKS cluster. See, go to the section one, EKS Terraform, and this is the main.go. Okay, I will explain the code and I will create the EKS cluster. And after that, we will go through the worker nodes components and see mm, this entire I'm deploying through the Kubernetes through the GitHub actions. I am taking the help of Terraform. Okay, see if I created any Terraform, it will generate one Terraform stateful file, right? That Terraform stateful file, it's a backend on S3 bucket. I'm storing that file and required providers. I'm taking HashiCorp AWS S3 because I'm entirely my cloud provider is AWS. That's why I'm choosing from HashiCorp AWS, and my region is US East one. Okay, and my local tag names and project name is EKS project. Environment is dev. Otherwise, you can prod like its entire Kubernetes is a production level deployment only. See, when you are practicing any Kubernetes lab, make sure you have to deploy a Kubernetes cluster through production level only. Don't create normal Kubernetes cluster and practice and destroy everything. This is a very wrong process because when you're practicing in that format, you can't observe what MNCs and startups they are following in the real everyday day-to-day process. See, this is the Kubernetes cluster. It's a production Kubernetes cluster deployment. You will get everything with a single click. Exactly how I'm creating this Terraform script, same script only in every company, in every startups, they are using the same format only. In the same format deployment also I'm using. Every company they are deployment in Kubernetes through the Terraform only, through the Argos, through GitHub Actions. Same thing I'm deploying today. See, my managed by Terraform and cluster name is local cluster name. See, my project name is CKS project. See, first I'm creating the VPC. CICD block is 10.0.0.6/16, and I enable DNS support through. I enabled DNS host name. My VPC name is EKS VPC and AWS Internet Gateway. I, I enable EKS IGW and subnets. One is private subnet and second is one is public subnet and second is public subnet 2 and private subnet and private subnet 2. Usually in our Kubernetes cluster, we are not giving the public access. We are giving the private access. That's why we are taking these two subnets. Through the two subnets only, we are creating the entire Kubernetes cluster. I will show you the how after creating that which subnets it's taken and everything. And NAT gateway for the VPC. I in the NAT gateway I choose the subnet is private IP, private subnet, and AWS root table I am creating as a public, and I'm allowing the security groups as a full traffic I'm enabling. Usually we can't enable the full traffic on the Kubernetes clusters because like whatever traffic we have to use same traffic only we have to enable. But I'm allowing the full traffic because this is the practice purpose for all uh, labs. I am using this entire Kubernetes cluster deployment only. That's why I'm created as a single time deployment and IAM role for the cluster. Here I given EKS Amazon.com services I'm given and I allowed And here AWS EKS cluster policy I given. I'm not given the administration full access. I just given the EKS cluster uh, policy only. And this for IAM node group. Here I given Amazon EKS worker node policy I given, and AWS EKS CNI policy I given, and AWS EC2 containerization registry read only I given. It will only read. It will not rewrite. It will just only read. And EKS cluster I given. This cluster name is local name cluster, mm, and role IAM role, and version. It's everything I given in the here. I will explain after that. First go through this file and access control I given, and VPC configuration. See, I choose the private subnet 1 and private subnet 2, and endpoint public access true. And dependency like a AWS role. First it will create the role, after that it will create this one, and EKS cluster this one, and EKS accessing, it's EKS accessing. I'm giving the admin access entry, and here I'm giving the admin AWS EKS admin policy I given, cluster policy I given. And coming to the node groups, there's a total three nodes it will be create, and three nodes it will created on the private subnets. It will you will not get the public subnets. Everything is private. Total three, desired capacity three, and maximum 10 and minimum three. It will be scaled whenever your traffic is increased. See, it's a AWS launch template node group ID and AWS launch template node group latest version. And dependence on, first it will create the IAM roles, IAM role policies, and IAM CNI and IAM ECR. After that it will create this one. And AWS auto scaling group, it automatically it will scale whenever your servers will be increasing. It's automatically it will be increased. And EC2 IAM role, I am creating one bastion server. In that bastion server I'm giving the EC2 IAM role. Here I'm giving the administration full access, because in that bastion server through I want to access many things. That's why I given the administration. Otherwise I can give the ECR permission, S3 permission, or but I given the full administration full actions, because entire these 22 videos I'm using this bastion server. That's why I created this one. And in this bastion server also I given EKS cluster admin policies. See, in AMI I'm taken Amazon 23 one, and instance type is T2 micro, and this instance is I choose EC2 admin policies and EC2 instance profile, and VPC and security groups I taken, and volume size 30, and EKS. In my cluster name is EKS. See, in this sorry, in my EC2 name is EKS, and this EC2 instance I am installing kubectl and EKCTL and Helm charts I'm installing, and EKS add-ons. These add-ons I am VPC CNI I am adding, and core DNS, see, proxy. See, these all things I already explained yesterday, right? Same thing I am creating. Here I'm given the Amazon EBS CID policies. This is the entire cluster policies. See, and if you are creating this cluster in manually means usually it will take minimum of 50 to 60 minutes, but this cluster it will be take only for 10 minutes or less than 10 minutes only, or like below 15 minutes only it will create. And coming to the output, you will get cluster name and cluster name API endpoint, and cluster ANR, and coming to the networking endpoints VPC name and everything you will get it, and node group output and EC2 output and storage add-ons. Coming to the variables, see here my Kubernetes cluster version is 1.35. If tomorrow if my cluster Amazon is released the new cluster like name is 1.36, I change it here and I will upgrade it. I'm a cluster policy by default I given the false. I'm not giving the add-on policy right now. That's why I choose the false. Okay. And coming this entire code I push to my GitHub. But before you are applying this one, I will explain from EKS Terraform ML file, because I entire code I'm applying through the GitHub actions, right? That's why first I need to explain this one first. See, first my name is EKS Terraform, and whenever I'm raise the pull request, it's automatically this EKS Terraform ML file it will trigger. Otherwise, if you pushed any code in manually, at that time it will not trigger, and you have to go and manually run it. And whenever if you pull request means at that time the event name is EKS Terraform PR plan or Terraform EKS apply or Terraform EKS destroy. At that time it will be displayed. And if your event name is if suppose if you are running as a manually, at that time Terraform EKS apply or Terraform EKS deploy, it will come in auto run. Like it's a pull request whenever you created the pull request, and if PR has merged automatically in the actually if you are know the Terraform means, usually the companies will follow this structure. Like uh, usually the Terraform engineers there will write the code and there will be push the code to their branch and there will raise the PR, and Terraform engineers there will be read their entire code and there will merge it automatically. uh, it will trigger the GitHub actions, and in background the vault will be run it, and it will create an IAM role. And this IAM role create the sorry in IAM user, in the IAM user secret key and access will be create. It will take that secrets and it will run everything in automatically. It will entire process, if it will take the 10 minutes means until 15 minutes the IAM user secret key and access it will be active. 1 hour entirely it's created automatically, it will delete the IAM user access key and secret key. This is the process actually we are following in, if you in interview also. If you are asked any interviewer has asked how you are deploying the Terraform through the AWS services means you have to tell this process. And my path is 1.eks Terraform, 1.eks Terraform. Here my code is there, and see dot github slash workloads slash eks dot terraform. This file it will be run. Whenever you change anything code, it will run this file. Or path is this one. Is based on everything is pull request. If you change the if you create the pull request, automatically it will trigger. And workload dispatch means if you run manually, like if you run manually, if you trigger, automatically it will plan and apply and destroy it based on your options. If you want to destroy means at the time you have to choose the yes. If you want to apply means by default it will be the name is no. Permission set sits it's a read, and this is the GitHub Actions workflows and GitHub dot reference. And this is the common settings for the job. Terraform in automation is true. Terraform input false, and Terraform workload directory is 1.terraform EKS, and Terraform state file key EKS slash Terraform state file. It means you need to create one S3 bucket. Any name you can take it. You need to create one S3 bucket. In that S3 bucket, it automatically it will create one file EKS slash terraform dot terraform state file. Here the file it will be created. This is the backup file. It will create there. And region, I'm choosing the US East one region. If you want to another region means you change the region here. Otherwise, you can change the region in the GitHub Actions. GitHub Actions password, secrets and variables there. And job is Terraform plan. Terraform plan for PR. If you raise the PR, it will create a Ubuntu instance, and it will clone the entire repository. It will go through this directory and Terraform. It will take the install the Terraform CLI and AWS secret key and access key. You need to configure AWS secret key and access key in the GitHub Actions secrets and variable, and AWS region also. In based on that region only, it will create the entire infrastructure in this region. Wherever you are creating the bucket name, see wherever you are creating the bucket name in S3 bucket, in that bucket name you have to mention here. And coming to Terraform validate and Terraform plan, and Terraform apply. If Terraform apply, if you want to the manual workloads like workbench dispatch means if you are manually go through the Terraform in the UI, if you run means um, at that time it will clone the repository. Same Terraform CLI install. It will take the AWS secret key and access keys and everything. And if you want to destroy means it will destroy it. Or if you want to apply means if first it will Terraform init, Terraform plan, Terraform apply, and finally you will get the summary how you can connect your Kubernetes cluster through the Bastion server and how you can access it. What is your cluster name? My EKS cluster name is EKS prod and the region is US East 1. You will get this kind of details. And coming to the, if you want to destroy this entirely means first pre-deployment, pre-deployment cleanup. First, in Kubernetes cluster, any namespace is there or any deployment is there, everything first it will go there and it will delete it everything. It will get kubectl get ns. It's communicating the kubectl. It's communicating as a service to service, pod to pod, and everything, and it will run it. If anything is there means it everything it will delete all namespaces. It's everything delete. And once it will delete means it again it will be destroyed. If still it is destroyed means it's fail means it will go and check it. Network interfacing, it will check it. If anything network interface it is there means it will destroy it, and again it will rerun the Terraform destroy. This is the entire process. Now I will be open the GitHub actions and just go through the actions. Before going to the actions, you need to go through the settings, go to the secrets and variables, go to the action. Here, you need to configure AWS secret key ID, AWS region, AWS secret access key, and Terraform state file. Usually, it's a one-time configuration, but in MNCs and any company, they will not choose this one because they choose the vault. But I'm not explaining this vault because this is not a Terraform section. This is the entire Kubernetes section. That's why I'm not explaining. Whenever the Terraform at that time, I will explain there. Otherwise, I am taking the DevSecOps series. At that time, I will explain. Usually, this is the same names. Go here and go to the README file. In the README file, I already given. See, AWS uh, access key ID, AWS secret key ID, and AWS region Terraform state file. These same things you have to copy it and you have to paste it here. And I 3 days back I configure and just create one IAM user. In IAM user, you have to create um, secret key and access key, and you have to configure here and choose the region. Is I'm choosing the US East 1 region. Try to choose your US East 1 region. Otherwise, if you want to apply another region, means try to create the that region and check the code wherever the US East 1 is there. At the time, you have to change there also. Okay, and one more thing, create one S3 bucket, any bucket name or S bucket, K bucket, any bucket name. Create it, same bucket name. You have to give here. Make sure the names should be same here. If single name it's fail means your Terraform it will be not work. If you not configure the S3 bucket means your Terraform it will be installed. Sorry, if Terraform it will be create all resources, but it will can't delete the resources. And if you want to recreate also means it will recreate it, but it will not delete your entire resources. That's why we are configuring the Terraform state file bucket name here. Okay, and everything is done. Now I'm just going back to the code. Just go back Terraform EKS. Terraform EKS, I already given everything here. Just copy it and you can use it. S3 bucket name should you store the Terraform state file. You can create any bucket name. I'm telling one more thing. And go to the actions, go to the workloads and Terraform, EKS Terraform, and just run, view run. Here, just go through here and just apply. It's by default, it's no. If you want to destroy means you need to select destroy it and type S. I want to apply run workloads. Yeah, it started creating. Now I'm just over here. See, it's clone the repository. Terraform setup is done, and AWS secret key and access key it's done. Wait 1 second. Okay, now configure the AWS credentials done, and we are applying, right. That's why destroying step it's blocked. And Terraform format means if code is not good format means if it will run means the your code will be get the good format. And Terraform init, Terraform up validate, and Terraform plan means whenever you can pull request at the time only Terraform plan will be run. Otherwise it will go through the Terraform apply only. In the Terraform apply, see it's creating all resources. It's creating see, AWS public subnets. It's creating AWS public subnet 2. It's creating VPC. It is creating. See IAM role. It's creating and everything. Usually it will take some time. We need to wait for some time. Entire infrastructure is created. See some of the blocks is blocked. Stages is blocked because this all is whenever it's destroying at that time it will work, but now it's everything is blocked. Okay, now it's created. Now first we will check the VPC. This is my VPC, and I'm just refreshing my VPC. We will check the VPC, and I will check the EC2 instance also. Yes, total two VPCs is there. Just opening my VPC. This EKS VPC is there, and subnets EKS public subnet, EKS private subnet, EKS public subnet to EKS private subnet. And root table, it's two created. One is public root table and one is another private root table. And internet gateway is created one. And next, elastic IPs. And see, EKS elastic IP it's created. And NAT gateway, its entire infrastructure is created. And NAT gateway it is created. Coming to the network ACL, see network ACL it's created. And security groups, its entire infrastructure it's created. See, uh, EKS cluster security group, all allowed all security groups it's created. It's created a EKS security group. And coming back to the EC2 instance, I'm just refreshing. US East 1, Northern Virginia. See, it's created three nodes: EKS cluster node, EKS cluster node, EKS cluster node, and this is the EKS. It's the batch server. Coming to the master, this is the EKS cluster. This is EKS cluster prod. To here, see, it's 1.35 Kubernetes version, and status is active, and it's healthy, and upgradation is 0. It's the latest version. And coming back to here, I disable the Kubernetes auto mode because I'm choose the infrastructure level, right. And coming to the computers, see EKS node group, total three node groups is there. And networking, see it's VPC and subnets and security group. And add-ons, see Amazon EBS CI drive and VPC CNI network, and EKS prod identity agent and QProx and CodeDNS capacities. We can use the Argo seed, but it will not know. Whenever the Argo CD concept came, at that time I will explain. And AKCD At the top, when the topics will came at the time, I will explain. And pod identity centers and IAM permissions dissolver and these observabilities and upgrade histories and backup and this not there in it, it's normal tag CEKS project, EKS Pro, dev and everything. And now we will connect our EKS cluster. Just go back and just connect. See one more thing I'm explaining. See in this Bastion server only, see in this EKS Bastion server only public IP is there, private IPs is there. Because it Bastion server, it's taken the EKS public subnet 1 and EKS VPC. Coming to here, EKS cluster nodes, if you choose, there is a no public IPs. Everything is private only. There's a two private IPs it's created. And public DNS also it's not there. Because it's created on EKS VPC and it's created on subnets. IDs is private. Not sorry. It's public subnets. See, EKS public subnet 2, it's taken. And if you choose another one, it will take the public private subnet 2. Okay, all it's taken the private subnets too. And no problem. See, everything it's elastic IPs, IPv4 6 and everything it's disabled. And if you choose here, this EKS cluster node group, these three nodes as allocated the security group is EKS cluster security group. But coming to here, this only EKS cluster only, it's allow the administration, it's allowed all security groups. But remaining here, it's created on some different one because this is the private instance, right? That's why on private we have allowed only limited only, but here it's allowed everything. Okay, now I'm going connect this one. Just connect to the browser only because I didn't configure the key pair. If key pair is there means I can connect in outside also, but I didn't configure any key pair, right? That's why I'm directly connecting to the browser only and go back and see summary. Go to the summary. In the summary, you will get the details to how to connect your cluster. See, how to connect your cluster after deployment. It's everything is deployment done, right? Your cluster name is EKS prod. We've seen already, and region is current region is US East one. And if you want, first you need to update kubeconfig file. If you update the kubeconfig file, your master node means it is the master Kubernetes. This master it will connect your all nodes. Well, three nodes is there, right? These three nodes, like the node group and master group. Right, I will explain here directly. See, here worker nodes is there, worker nodes is there. This worker nodes, it's connecting to the master. It's connecting to the control plane. It's a master. That's why we need to figure the kube config update. Okay, so just copy this one. Just I will explain AWS EKS update kube config file region US East one. Name is my EKS prod. Okay, you just copy, go to the root user and see, add a new context. This one slash ECT slash root dot q dot config. If you go here, cat uh, root slash dot uh, wait cd. Okay, we leave this one and first we will check that kubectl get nodes. If you run this command, it automatically you will able to see the two nodes, three nodes. See, Total three nodes is there. Same here also three nodes is there, right? Now your control plane is connected your node groups. And now if you check the any pods, currently we didn't deploy anything, right? If you run kubectl get pods, these pods for the AWS node and this for the core DNS is the EBS CPI controllers and is a EKS pod identities agent. See these pod identities and EKS bit drive and this everything is three is there. See everything three because my three instance is there and three is there everything. Your DNS and everything it's three is there because it is taking this one. Sure, wait 1 second. Yeah, it's taking daemon set. Yesterday I have explained the daemon set is one pod in one node. That's why if three pods is there, three nodes. If tomorrow it increased one more server, automatically it will create a one more also. Okay, see, it's a three replicas. It's everything. It's run on one. Okay, see, and it's coming to this the replicas. Total replicas is there. I will explain what is the replicas and everything. And I hope you got the clarity and everything right. Now, let us go to the base concept is worker nodes components. Okay, see, before jumping to the hands-on, you need to clearly understood one of the important thing is how exactly our application is running inside EKS, sorry, ECS, Elastic Container Services, or Elastic Kubernetes Services. ECS means forget, and EKS means Kubernetes. Okay, is both are same. If you understood any one also, it's no problem. Uh, okay, coming to okay. Now I hope you understood the Terraform, and I hope you understood the how I configure the Kubernetes cluster and how I need connected the control planes and master node to the node groups. You got the clarity, right? Now uh, we will understood about the workload components on ECS and EKS. And coming, imagine in your company, you have a build an application. Now your job is run an application on AWS. You didn't just say run the application, run the app. Instead of in your defining what is app, this how many CPUs we need, how many memories we need, how many copies should I run. This is the exact setup. It's called as a workloads. It means in ECS or ECS, if you take the EKS, see you have a five microservices code is there. Five microservices code is there. You want to deploy this five microservices code to the workloads components. And coming to uh, you want the CPUs and memories and pod and environment variables, everything you is there. This is the entire blueprint. This is the entire your application task. You are giving the task to the pods. Each microservices you want to run in one pod. Five microservices, five pods. Now, if one microservice is it's crashed, you have only four microservices. Is that means you don't have any replicas. Also, it's not there. That's why if one pod is crashed, you automatically one more pod is there, it will handle that. And total three pods, if the user will be hitting uh, to the the load balancer will go to the first pod and second pod and third pod. Same like okay, uh, auto scaling. And if one pod is crashed, automatically the replica will be automatically created one more copy. And second component is services. Same like whatever I explained. See, your app is like your app is always running, and if suddenly it's crashed due to some another reason, and you need to restart. No, manually, like you want to maintaining the desired capacity at 3. It's auto scaling group, and suddenly your one pod is crashed, and immediately another pod is created because of you created the replicas count. Based on that, it will recreate it. Coming to the cluster, now where we are all you need to run this all pod services, Kubernetes, and everything. This everything inside our Kubernetes cluster. Cluster is like a group of mission, and inside the cluster, those missions, like if all containers will be run, all worker nodes like EC2, like finally working nodes, there are actually many EC2 instance is running. Like whenever the load is coming, automatically the new instance it will be created. Whenever the load is decreasing, automatically your instance will be coming to the down. Like see what will do that EC2 instance. EC2 instance, what will do, right? First, pull the image, pull pull the image in Docker, Hub, or ECR repository, and then run in your application. It's in pod, and its handle traffic. Without worker nodes, nothing you need to run, right? You have a cluster is there, but without EC2 instance, without node groups, it is possible. These all things is possible. It's can't pull the your image, it can't run, it will not able to handle everything. If EC2 instance is there means everything it is possible, right? No, now you got the clarity uh, why we are using the EC2 instance and everything, right? Now, uh, now tell me, uh, you understood, right? Still now everything. If you're not understood anything, just ping me the uh, comment section, and I will be explain your doubts and everything. And let us go to the hands-on demo and go through the Kubernetes and go through the workloads components. Here, deployment, pod, and replicas. See, before jumping into the ML files, and I need to simplify you these ML files. I need to explain pod and replica sets and deployment. See, in Kubernetes, in your application, doesn't run directly. You need to go this process. First process, you need to create a pod. After that, you need to create a replica set. After that, you need to create a deployment. See, if you understood these three concepts, 100% you can understood pods, replica sets, deployment. You can 100% you are the knowledge, and you can clear the interview questions also. Let me tell you one small story about these three topics. You will be better clarity about these topics. If you have still any doubts also, you will be clear these doubts. Imagine uh, if take any company, in their company, what web application they want to deploy. Okay, if they want to deploy means they want some requirement. some requirement. So some spelling mistake is there. Is there? The requirement is app should run on container. App should run container. Containerization. Continuously app should will run. The app, your application, it will run on containerization, and that app should run continuously. The users will be run. The users will be access this application without downtime and everything. And second, if application crashed automatically, it if application is crashed means the pod will be crashed. This pod will be crashed automatically. It will be create one more pod. It means recreate or restart through the help of replica set. In replica set, we have to take the replicas 2, 3, or means if we in replicas 2 means it will create two pods like that. You know, multiple users and multiple instance. And if the developer updated the code, updated the code, and I run the pipeline, it's automatically it will get the users uh, the new features without downtime. Without downtime, the users will be used. Now my question is, can a single pod handle this? No, right? That's why first I need to explain the pod. Pod is a one server. It's uh, now I will explain the few codes. First I will be take the code is the pod. This pod I will be take the code. This is the pod and replica set. Sorry guys. Replica set, and I will copy the code. Increase the size. Okay. And now finally deployment. Deployment. See now everything is clear, right? I copied the entire code and everything. See, uh, first I will explain the pod and replica set and deployment. You will get the reality side. See, in this code, first I will explain the code. First, see this YAML file. First, API version is V1. It means Kubernetes API version. I will write its API key version. API services. This services version is V1 and this V1. And this version for the only pod level. Okay. And kind is pod. This is the object for the pod. And this is the metadata. And this metadata name is to identify the this pod name is my app. Okay. And the label for this pod, this is web app. Okay. And this front end and is the type and containerization. In this containerization, my containerization name is Nginx container and image name is this is the Nginx image. It will take directly public image of Nginx. It will deploy it. Now, uh, I will explain it one more time this code because if you understood this code first time only, upcoming videos code you can easily understood. See, API version means which API we are using, and kind means pod, and metadata means name for the label. This entire metadata for name for label, and label is important because is used for the replica identity font. Web app is web name only. Identify the replicas and to increase the replica sets. That's why what we have to define in the pod level means for the Nginx image. But remember one thing, label is web name. To the web name only, it will create the instance and everything. Now coming to the replica sets, it's scaling and self-handling. I explained right yesterday for the self-handling and everything. And coming to here, uh, app version, API version is app slash v1 means it's API version for the replica set. For only for replica set, object type is replica set, and web rs means it's the name of the replica set, and its total replicas I'm taking three. It means we want three pods. Same pod, we want three. And selected means uh, it's connect replica set for the pod level. This select process. For the pod level. See, label, see, match label, app is a web app. This is the web app. Okay. And coming to the important thing is here, if label is not matched means it will not communicate. It will override the replica set, won't be managed for the pods. And how the new pods should we be recreating means if pod will be crashed means it's self-handling, right? It will automatically identify, it will automatically recreate everything. Okay. And coming to the deployment, this is the API version for the deployment app.v1 and kind is deployment, it's object name. And coming to the replicas, same for the deployment also. In the deployment, it will create three, and replica sets, it will create three. For the pod level, it will create three. And here same, I am choose the Nginx. See, everywhere I'm choosing the Nginx names. Nginx name, I image name I taken because this is the separate code. This is the separate code, and this is the separate code. That's why I cleared. See, this is the only pod level. See, if you deployed only pod, if you deployed only this pod, if you not deployed replica set, if you not deployed the deployment file, if you only deployed this one, Nginx it will come. If image it's crashed means you are not able to recreate it. If you deployed this one, you will get if you deployed it, it recreate one more time. If that deleted, it will recreate one more time. If you use this one means deployment means you are able to access the application with container port number is 80. But here I didn't mention any container port. It's only pod. Pod means it will recreate. You are not able to access that application. Here The replica set means it will recreate. If the pod is crashed, it will recreate. But you are not able to access the application because the container port number is I didn't given here. But here I given the container port number. It's 80. Your access, our application should be access. See, we want pod, we want replica set, we want deployment. If you only pod means if you are not able to create the replica sets. If you replica set is there means you need to create a pod and you need to create a replicas. It's self-handling and everything. If you have a deployment file means you need to create a pod, you need to create a replica sets, you need to create the deployment, and finally you need to access your application. If 100 users as there means it will detect and it will scale our applications, it will scale our nodes and it will scale everything. And if it's that means automatically it will recreate your application. Same Nginx I taken. It's identify. Your see here the replica set I given 3 and metadata app I given Nginx. See this metadata I given Nginx. If I given wrong name here, the replica set it will not identify it and it will not create. Coming to here, I given the web app for the replica. I given the web app. Coming to the metadata, I given the label for the web app. It will identify the web app. Here coming to the web app I given. But replica set I didn't written the code. That's why if prod crash means it will not recreate it. I will show you the when the hands-on came. Now in this code, the replica set it will be created. And now this is the advanced level of the code. It will roll back and control version is there. Easy to roll back. If you change the any image also, the Kubernetes will be updated the pod on time. One by one it will update. Means the old pod will be there. And if you updated the image means it will new pod it will be create. Once new pod it will create and old pod will be delete and new pod will be there. In the old pod you created the 3 pods. In the first it will created the new 3 pods and after that old 3 pods it will delete and new 3 pods the users should be access. If suddenly if the new pods it will be it's something it's going on wrong, you can easily roll back these 3 old pods. You can easily roll back and you can delete new pods and you can roll back to the old pods and the users will be access the old pods also, right? And without downtime, you can do this process without the downtime because the replicas is there, pods is there, and deployment is there, container port number 80 is there, and load balance is there, everything is there. See, you can access through the cluster IP or node port or load balances. This is the different concept. This is the services. This topic I will discuss tomorrow. Today I will just discuss about the container port number. Now, pod is just a basic unit. This is the just basic unit. Pod, it is a basic. It's a just basic unit. Coming to the replica set is scaling, scaling less handling. And coming to the deployment, see here production controller, production controller. If you understood these 3 codes, once again I will explain. This is the only pod. If pod deleted means your application entirely will delete. Here, your application is running, but you are unable to access. And if the pod is deleted, your another pod it will be created. It's self-handling. Coming to here, it's a production controller. Pod will be running, 3 pods will be done, and self-handling and everything. The container port number is 80. You are able to access everything. This is the entirely. And now we will discuss about the hands-on. Now you understood the code level. Now coming to the deployment level. First, install the Git. Okay, I will just refresh. Timeouts. That's right. And first go to the root user. First, once again, will check it. My cluster is ready or not. Yeah, it's my cluster is ready. And first, I will install Git. Uh, yum install Git because I need to clone my code, right? See, whatever the same code there, same code I written here because I written some default also, some comments also I written because if you understood this deployment pod and replicas, you can easily see in this entire 14 section 20 seconds, same repeat pod, replica sets for deployment, same thing. See, if you give the services, cluster IP, load balancers, everything. This is the tomorrow's concept. This is today is just for creating the application. Tomorrow is accessing the applications. Okay. Now I will just go back, just copy the code, go to the Kubernetes cluster. Okay. And git clone, yes, and cd Kubernetes and cd ls. And first we will go through the pod because first I will explain one more time. This is the entirely theoretical pod I will explain. Now I will explain hands on. And first I will go through the pod level. Okay. First I will be check the code. Uh, cat pod. Yeah, code is there. And now I will deploy this one. Just run kubectl apply minus f pod dot aml. See, pod slash my app is created because my app is metadata name, app name. My app is app name, web app name. See, is metadata name. Okay. Now I created simple pod. Um, this is the single pod only, single pod application. And now I will just check the pods is running or not. Kubectl get pods. See, my app ready means one replica, one pod, status is running. 44 seconds back, it's created. Now it's only for one instance. See, one on one. It's only for one instance. No scaling, no self handling. Now, if I deleted this pod, it will not recreate. See, kubectl, wait, kubectl delete pod name is my app. See, my pod, my app is deleted. Now I deleted everything. I wait for 2 seconds. Yeah. Now again I will check it. Kubectl get pods. See, there is a no pods is there. See, a namespace means this is a different concept. I will explain upcoming days. And today you just focus these concepts. The pod is not there. Wait, I will again I'm running. There's a no pod. Your entire application is deleted. You know, see, Kubernetes did not recreate it. This is the why using the pods in the Kubernetes. We can't depend on the pods. We can't depended entire application through the pods only. We need to depends on the replica sets. We need to depends on the deployment and everything. Now you got the clarity, right? Pod I created, I deleted, but still it is not recreated. Now I'll go to the replica set. See, again I'm going to the pods. It's not created. Now I'm going to the replica sets and ls cat replica set code is there. And now my kubectl and apply minus F replica set. Replica set created app slash webrs means it's replica set. It's created. See, metadata means webrs. It's created. Replica set. It's created. Now, a replica set is created, and this ensure is multiple pods. I see kubectl get pods. It will create three pods. Three pods it's created, and if I deleted one pod also, it will recreate it. And see now three pods is running. Three pods is the replicas. See, replicas three. If I choose the four means it will recreate the four also. Okay. And now I will just check it the replica set. Now I'm just kubectl get rs. Rs means replica set. See, web rs desired capacity is 3, current 3, and ready 3, and 73 seconds back it's created. Now I will delete one pod and I will wait some time and it will recreate one more time. It will recreate automatically. Kubectl delete pod, and I will delete this pod, copy the pod name. See, pod webrs 62 jmc, it's deleted. Now I'm deleted and just kubectl get pods. Wait, see, it's recreated. 12 seconds back, it's recreated. See, previously B7 BB9 is there. B7 BB9 is there, and GHS J double also is there. But G2 J double G2 JMB I deleted, but immediately it's created. Now I will be delete one more pod, copy. I deleted. Now I'm just running kubectl get pods. See again 4 seconds back it's recreated. Without now users will hold access, right? See, this is the one first pod, and this is the second pod, and this is the third pod. Here your microservice is running. Here your microservices is running. Here microservices is running. Entire application is running. This is the load balancer. The user will be hitting the root table. This is the user hitting the root table. Wait, it's gone. Pencil. Yeah, yeah. The user will be hitting the root load balancer, and load balancer based on the traffic, and it will redirect right or communications. If suddenly increase this server, it will delete it means it will recreate one more pod and it will attach to the load balancer. This is the entire process. I hope you got the clarity right. Now, still now you are unable to access these applications uh, because you didn't deploy this application. You just it's running the applications, but through the users you didn't deploy it. Now let us deploy this application and ls and cat and deployment. See, this is the entire code, and now we will create a deployment, and this is the what usually a real production deployment I'm deploying, and kubectl apply minus f and deployment I created. Now I will check kubectl get deployment. So yeah, see, nginx deployment. See, metadata name is 3. Metadata is name is 3, and 3 is running. Up to date 3, available 3, age is 18. Right? This is our deployment is running. Now we will check the replicas. kubectl get rs. See, this is the only replica sets. This is the deployment. See, nginx deployment, it's running. Now kubectl get pods. See, 3 pods is running. Replica set is running. See, now you got the clarity, right? See, deployment. See, deployment, our application to taking the help of replicas and another taking the help of pods. If pod is crashed, the replicas will be created one more time to accessing application to deploy the application to the deployment. And tomorrow, after deployment, here it will be adding to the services. See, these services it will be added tomorrow. We deployed application. We allowed the port number, container port number. Now you want to access the application, right? These are the services, the load balancers, node port, and service port. Through tomorrow, you will be able to access. And today, you got the clarity, ports, replica sets, and deployment. Now, we deployed entire application, right? Now we need to check the downtime, everything, right? And uh, now we will roll back it and update it, and everything we will see. Now, kubectl set image deployment. Where is deployment? Okay, yeah, I will deployment slash nginx deployment copy nginx deployment and space nginx is equal to nginx and I'm choosing the latest. See, kubectl set image deployment slash nginx deployment nginx and nginx latest. This is the my latest images. This is just it will be replace this image to this image. Now this my latest image is this one nginx latest. Now previously my image name is nginx 1.4.23. Now it will replace it to this image and it will deploy it. And nginx deployment, see, nginx deployment is the metadata name, and nginx in deployment kubectl set image deployment. This is the deployment, and this deployment and nginx deployment metadata, and this metadata nginx name is nginx. Here latest image nginx, it will recreate here. Just click enter, and it's my mistake. The I added the add one more s. Now I will create, yeah, deployment dot apps nginx deployment image is updated. Now you will check it. Kubectl get pod slash minus w. See here, images is updating. Images updating. 38 seconds back, 50 seconds back, 36 seconds back. It's images, it's updating. Without downtime, it is updating. And now we will describe the nginx mods. And before describing the pods, and we will be roll back our image, and just our roll back our image. This is the kubectl rollback restart deployment nginx deployment. If you reach, see, it's rollback, and now if you go back kubectl get pods, see, immediately it's rollbacking. Previously little bit we it slowly we created, right? That's why now, see, it's immediately it's rollbacking 1 second back, and everything it's creating, right? The nginx deployment it's completed and it's running, and it is old images it's terminating, and it's creating. See, this is the way. Now if you exist and if you run again, see, it's running again, it's back. Because previously why it is not showing means we took a lot of time. That's why it's updated and it's deleted. That's why it is showing. That's why it is not showing. I'm thinking it's because of it's updated and it is fastly it's updated. Now whenever now I roll back, right, immediately I run the command. See, at the time it is showing, and now it's everything is running. Now if you want to check the sorry, if you want to check the status of the rollback also, if you want to check the rollback status means, see, rollback engine is successfully rolled out thing here. Now you understood that rollback concept, you understood, and how to create the new images and everything you created. Now we just describe our nginx deployment point, right? Now just kubectl describe deployment and nginx deployment copy. This is the describing and everything. How, see, the replica sets and everything. I'm roll backing again. I roll back and everything. It is showing the status and messages and everything. Deployment controllers, and this entirely it will show the process what you did and everything. You see container port number 80, and previously image is latest, and again we roll back, and the replica sets it's created 3. Now it's coming again back to the same image. This is the entire process. Now after process you can delete your kubectl uh, deployment and replicas. If you're not deployed also, if you directly go through the github actions also, it will delete kubectl, delete, delete minus f deployment. Yeah, it's deleted again. Now it will not create again, because I deleted the deployment file only. I created deleted only. See, kubectl get pods, it will only now I delete only deployment file. I didn't deleted the pod, I deleted entire deployment. That's why it's getting this one. Now kubectl deployed minus delete, which now it's pending replicas, right? I deleted. Now if I go back, kubectl get pods, nothing is there. And I hope you understood the today's concept, uh, core components and deployment and replica and pods. And tomorrow concept, and we will discuss about services like cluster IP and load balancer and node port. We will discuss, and we will access the application to the 3. Node port we will access, cluster IP to we will access, and container we will access these 3. Okay. And after completing the practice, please go to the Terraform actions and destroy it. Just go here and just destroy, and just type as run workflows. If unfortunately if you didn't deleted anything in the Kubernetes pods or no, any load balancers, everything is there means no problem. This will automatically delete it. Okay, we will wait for some time. It automatically delete. Maybe you will also get some clarity if there any issues or not. That's why. See, it is destroying. First, it is checking the pre-deployment cluster checkup. It's checking. First, it will installing the kubectl gets and everything, and it's just checking anything is there. Total three clusters is there. Now, if any Kubernetes namespaces or anything is there means first it will delete it, and after that it will if anything still is there means it will delete. After that it will delete your entire Kubernetes clusters, because this is the entire product Kubernetes clusters. Some members, like few members are messaging me in LinkedIn, I created the Kubernetes cluster but I am not deleting, could you please delete, I will you uh could you please help me, like I know, like too many members following my documentations, but they're confusing to uh, uh, handling the confusing working on the this process, because whatever I am explaining, everything is a real company's documentation process only I am explaining. That's why if you're following my documentation, if you join any company also, right, maybe you will not able uh, to doing the task. It's dead easy because I followed this tutorial everything, because that much of knowledge I will give you. And if you are really interested, you can watch the videos. If you're not, means bye bye. Okay, because my YouTube channel is everything is a production. That's why I'm created in the production Kubernetes clusters and everything. Usually it will take some time. We will wait, and after that we will close this section. Yeah, it's destroyed. Now if you go and check here, just refresh it. Everything it's destroyed with a single click. We entire app created the infrastructure. With the single click, we destroyed the entire infrastructure. See, everything gets destroyed. And you check the Kubernetes cluster also. It's everything it's destroyed. And tomorrow's video we will discuss about the services and everything. And thank you so much, guys, watching our episode 2 and episode 3 for services. This is the very biggest concept why IPs is continuously is changing. If IP is changed, how to access the application, everything we will discuss today's tomorrow's concept. Thank you so much, guys. Bye bye.